You know, we trust that our most sensitive health data is kept private. It has to be. But what happens when the very definition of private gets challenged by an AI that can literally see things we can't? Today, we're diving deep into this new frontier of privacy in medical imaging. So let's start with what feels like a super simple question. Imagine a hospital takes your MRI scan, and before they use it for research, they remove your name and your patient ID. It's anonymous now, right? I mean, it seems like it should be, but the reality, it is so much more complex.
So, there's an official term for this whole process, and it's called de-identification. This is the standard practice, the thing that's guided by big regulations like HIPAA here in the US and GDPR over in Europe. For decades, this has been the bedrock of how we protect patient data, allowing for all this crucial medical research without, supposedly exposing who you are.
Okay, let's get into it. To really understand the challenge here, you have to see that just blacking out names on a file, well, that's just scratching the surface. Now, this is a really important distinction. You've got anonymization on one hand. That's the extreme version where you strip out everything that could possibly identify someone. The problem with that? Well, you also end up stripping out data that's absolutely crucial for research, like the specific settings on the scanner. So what the medical world actually uses is de-identification. It's more of a balancing act. They remove the obvious stuff, the direct identifiers, but they keep the useful scientific data. And that trade-off? That is key to this whole story. But the identifiers we're all used to thinking about, like names and IDs, they're only one part of the puzzle. The real challenge today is the information that's basically hiding in plain sight, right inside the image itself. You see, a medical file is really two things at once. First, you have the metadata. That's the data about the image, your patient ID, the doctor's notes, even the scanner model. And that's what de-identification has traditionally focused on. But then you have the pixel data. We're talking about the image itself, and that is where things get really complicated. This breakdown shows it perfectly. Over on the left, you've got the traditional target, metadata. Think of it like your patient ID tucked away in some technical file header. Standard de-identification tools are built to scrub that stuff out. But the real surprise is on the right side, the pixel data. We are talking about text that is literally burned into the pixels of the image, or something even more subtle, like the unique 3D structure of your own face that can be pulled from a head scan. The image itself can become the identifier. Okay, so naturally, the industry developed new tools to fight back. You've got defacing algorithms that can blur or remove facial features from a 3D scan. And for that burned-in text, you can actually use another AI to recognize the text and just block it out. So it really seems like the problem is solved, doesn't it? Right. So we've scrubbed the text, we've blurred the faces, we should be safe. But this is where the story takes a really sharp turn. Because the biggest risk isn't what a human can see anymore. It's what an AI can see. Okay, get this, because this is a truly mind-bending finding. Researchers discovered that an AI could look at a chest X-ray and predict the patient's self-reported race with startling accuracy. But when human radiologists, experts, looked at the exact same images, they couldn't do it at all. It was definitive proof that AI is finding patterns in the data that are completely invisible to our eyes, and those patterns can link back to our most sensitive information. This whole thing opens the door to something called an inference attack. And this isn't about finding a name someone forgot to delete. No, this is about using a powerful AI like a digital detective to deduce information from all those subtle patterns in the pixels, information that was never explicitly there to begin with. So how does an inference attack actually work? Well, this diagram shows it beautifully. The AI isn't reading text. It's analyzing these incredibly subtle pixel patterns. And from those patterns, it can infer things like demographics, the specific make and model of the scanning machine, or even unique details about your anatomy. Now, any one of these clues on its own is probably harmless, but when an attacker combines them, they can create a unique biometric fingerprint that points right back to a single individual, totally shattering the illusion of anonymity. So yeah, that feels a little alarming. But the story doesn't end there. If AI is creating these new privacy challenges, could it also be the solution? Well, the answer is yes, and the ways we're doing it are incredibly clever. So this first technique is called federated learning, and honestly, it's a game changer. The core idea is brilliant. The sensitive data never leaves the hospital. As you can see here, each hospital trains its own AI model on its own private data. Then, instead of sharing the data, they only share the lessons the model learned, these little mathematical updates. A central server then combines all those lessons from everyone to build one super smart model, all without anyone ever having to share a single patient scan. The other major approach is even more futuristic: synthetic data. In this case, a generative AI, kind of like the ones that create art or text, studies a real data set of medical scans. It learns all the statistical patterns, and then it generates brand new, completely artificial images that look just like real scans, but they don't belong to any actual person. It's like creating a perfect digital stunt double for the data. You can train your AI on it all day long without ever risking a real patient's privacy. So, federated learning, synthetic data, problem solved, right? Well, not quite. Because just as we develop these brilliant defenses, a whole new privacy battlefield emerges with new kinds of attacks designed specifically to break them. Turns out, even these advanced defenses aren't foolproof. Remember those shared lessons in federated learning? A clever attacker can sometimes reverse engineer them. It's like reassembling a shredded document to reconstruct the original private images. That's gradient leakage. And for synthetic data, you've got something called model inversion. This is basically like a hacker tricking that AI stunt double into describing the real actor it was based on in such perfect detail that you can figure out who the original person was. And this really brings us to what the researchers themselves are saying. As this quote makes clear, this is a continuous technological arms race. Every new defense we create just prompts a new kind of attack, which means there's this constant effort to find the perfect balance between protecting patient privacy and making sure the AI models are still accurate enough to actually help people. And that's really the ultimate takeaway here. There is no magic bullet for privacy in the age of AI. It's not a problem we're just going to solve one day and be done with it. It's a continuous balancing act between protecting our most personal data and pushing forward the scientific progress that can help us all. Which leaves us with a final, really provocative question to think about. When our technology can see patterns in our data that we can't even see ourselves, patterns that can be linked back to us in the most surprising ways, what does our privacy truly mean anymore?